Hey guys, it's Mrs. Marquette. Welcome to my home. Today we're starting a brand new chapter. It's called the Factor chapter. In this chapter we're going to be doing all sorts of adding, subtracting polynomials, but also a lot of factoring, like the name of the chapter. So to start off, we're actually going to talk about evaluating exponents and different rules that go along with exponents. So this warm-up should feel pretty familiar to you. If you have 2 to the 4th, we want to know what that power means. We know that that power means multiply my 2 by itself 4 different times. So 2 is my base, that's the number that I'm multiplying. I've got to multiply itself once, twice, 3 times, and 4 times. So I know that 2 times 2 is 4, times 2 is 8, times the last 2 is 16, so we know that 2 to the 4th is 16. Not too terrible. But now if we've got number 2, I now have negative 2 as my base. Whoops. So I'm going to multiply negative 2 by itself 4 times. So negative 2 times negative 2 times negative 2 times negative 2. I'm still going to have 16, but I need to know if it's positive or negative. I know that if I multiply a negative by a negative, that becomes a positive. By another negative, becomes a negative. By a 4th negative, I'll have a positive. So since I have an even number of negatives here, I just get a positive 16. And this last one. Here, notice my negative is not in parentheses. When we look at our exponents, this exponent is only actually attached to the one thing there next to it. So when I was over on number 2, that exponent was attached to the parentheses because that's the thing right next to it. So I had to multiply negative 2 by itself 4 times. That is not the case with number 3. The negative is outside, so I have a negative outside, and then I want to multiply 2 by itself 4 times. So I have negative 2 times 2 times 2 times 2. I only have one negative, so my final answer is negative. And then we know that 2 times itself 4 times is 16, because we've already done that. So our final answer is negative 16. And my last problem. Now I've got 1 over 2 to the 4th. Well, 1/2 is what I call my base. So this is going to be 1/2 times itself 4 times. So 1/2 times 1/2 times 1/2 times 1/2. If you are not remembering your fractions, multiplying. To multiply 2 fractions, we need to multiply across the top and multiply across the bottom. So in this one, multiplying across the top is pretty easy. 1 times 1 times 1 times 1, that's just 1. So then on the bottom, I need to multiply 2 times 2 times 2 times 2. We've already done this 3 times. 2 times 2 times 2 times 2 is 16. So our final answer is 1 over 16. So hopefully that jogs your memory a little bit about exponents. The big thing for me is that that exponent is only attached to the one thing. So when it's attached to parentheses, I have to multiply everything inside those parentheses 4 times. When there's no parentheses, the 4 is only attached to the 2. So it's only attached to the one thing next to it. So number 4, I still have those parentheses. So that 4 is attached to everything in those parentheses. So now we're going to talk about some properties of exponents. These things you will have in your guide on a quiz or on a test, but they're going to be important to get comfortable with as well. So if A and B are real numbers, so remember a real number is just any number that you can think of. It can be a decimal, it can be a fraction, it can be a whole number, positive or negative, and M and N be integers. Integers are positive or negative counting numbers. So we have 0, 1, 2, 3, 4, 5, 6, 7, etc. And we also have negative 1, negative 2, negative 3, negative 4, negative 5, and etc. So A and B can be any number. M and N, our exponents, are going to be actual integers. So the first thing is the product of powers property. So here we have the same base, A and A, but I'm multiplying them. When I'm multiplying 2 powers, I'm going to add their exponents. So an example of this would be 2 to the, let's go, third power times 2 to the fourth power. I have the same base, that 2, so I keep the base, and I'm going to add my powers, 3 plus 4, so I get 2 to the 7th. Okay, not too bad. Power of a power, that means that I have a power, a to the m, and I'm raising that to another power. When I have a power raised to a power, I'm going to multiply my powers, so a to the m times n. An example of that would be 2 to the 3, all raised to the fourth power. Let me actually make this one a little smaller. So if I've got 2 to the 3 raised to the fourth power, I do 2. This time it's 3 times 4, so I get 2 to the 12th power. Okay, so that's power of a power. The next one is power of a product. When I have power of a product, meaning two things multiplied by each other, what I need to do is make sure that I take that power, and that power gets distributed, in a sense, to each of my two factors, each of the two things being multiplied together. So instead of a times b to the m, I want a to the m times b to the m. So that would be like if I had an x and a y all squared, that really means that I've got an x squared and a y squared. Then we have the negative exponent property. If I have a to the negative m, meaning I have a negative in my exponent, that's going to say to me, I'm actually have my base in the wrong spot. So right now it's in the numerator. I'm going to keep the same base, but put it in the denominator. Okay. In the same way, if you have 1 over a to the negative m, that means, okay, that negative says I'm in the wrong spot, so I'm going to take the reciprocal. In this case, the reciprocal will flip that fraction, and I'll have a to the m over 1, or just a to the m. So the big thing with that negative exponent is whenever you see the negative exponent, you're thinking that's in the wrong spot. If it's in the numerator, flip it to the denominator. If it's in the denominator, flip it to the numerator. The zero exponent property. This is kind of a funny one. You kind of have to memorize this one. We have a to the 0. A to the 0 every single time is going to equal 1, no matter what a is. You could have 2 to the 0. That's 1. 3 to the 0, that's 1. 4 to the 0, that's 1. 1,000 to the 0, that's 1. You know I could keep going with this forever and ever and ever. 200 to the 0 is 1, and so on. So this one I'm going to star because it's kind of a different one. The next is quotient of powers property. We have a to the m over a to the n. That is going to equal a, so the same base, to the m minus n. So an example of that would be 2 to the 4th over 2 to the 3rd. 2 to the 4th over to the 3rd is 2 to the 4 minus 3, which is 2 to the 1st. Or we could just say 2. So if you see a fraction, you're going to take and subtract those two powers. And the last one, power of a quotient property. This is kind of like power of a product property. If you have parentheses and an exponent outside of your parentheses, that exponent has to apply to everything inside your parentheses. So here what that means is I'm going to take my m, and it has to apply to my a on the top, and it also has to apply to my b. So a to them over b to the m. An example would be if I had x over y squared, that would really be x squared over y squared. So those are all of my properties. I'll highlight the ones that you will get on your guide. What you have to know how to use is this table. So if you see an A for a to the m and a to the n for that product of powers property, you have to understand that that base is going to be the same. So it has to be the same number or same variable being multiplied by each other. If you have an a to the m over a to the n, like the quotient of powers property, you've got to know that that has to be the same base in order for you to subtract those two powers. So let's do a couple examples so that we can get ourselves kind of understanding here. Number one is 2 to the 3 raised to the 4th power. So the first thing I'm going to do is think, like, what property is this? It looks like I have one base, just the 2, and I have a power raised to a power. I think that's going to be the power of a power property. So the power of a power property says that a to the m, all raised to the n, equals a to the m times n. So that's going to mean for me is that I'm going to say 2 to the 3 times 4. 2 to the 3 times 4 is 2 to the 12th. You can plug that into your calculator and get your final answer. I'll leave it as 2 to the 12th just so we can see our work. Number 2 is 3 over 4 raised to the 2nd power. We see that this is the quotient of powers property because I have a quotient and then I've got a power on the outside. What we see from our property is that 2 has to be applied to both the 3 and the 4, the numerator and the denominator. So this is going to be 3 squared over 4 squared. Our 3 squared is 9, our 4 squared is 16, and that is our final answer. If you wanted to plug that into your calculator and get a decimal, that would be fine, but 9 over 16 is a good answer there. The next one, number 3, is going to actually be a couple steps. The first thing I notice is that I have one base and I have a power raised to a power. So that's power of a power property. I keep my base and I multiply my two powers. -1 times 2. We know that -1 times 2 is -2. But I also notice that I still have this negative exponent going on here. We know that our negative exponent means that my base is in the wrong spot. So I'm going to flip it. Instead of being our 5 to the -2 power, I'm going to have 1 over 5 to the 2nd power. Notice my 5 still is positive. And now that I've changed my 5 to be in the denominator, I no longer need that negative exponent. Now it's in the right spot. Then I can reduce, or simplify rather. I get 1 over 25, since 5 squared is 25. Number 4, -2 to the -3 times -2 to the 9th. Here, notice that even though they're kind of a more complicated number, -2 and -2 is still the same base. So I can use the product of powers property because these two things are multiplied together. So I keep my base, -2, and then it looks like I'm going to add my powers. So -3 plus 9. -3 plus 9 is a +6. And I can plug that into my calculator to get my final answer. On this one, I'm actually going to do it all the way out because this is going to be 64. And since this is an even power, I know that I'll have an even number of negatives. So an even number of negatives is going to get me a positive final answer, +64. Okay, this next one, r over s to the -5 squared. We see this power here. I know that that power has to go to both my numerator and my denominator. So on the numerator, I get r. We can say that this is r to the 1st. r to the 1 times 2. And on the bottom, I get s to the negative 5 times 2. Because a power to a power, I have to multiply those powers. So in my numerator, I get r squared. In my denominator, I get s to the negative 10. I would like to be done, but I have a negative exponent. You are not done until you have only positive exponents. So my r squared is okay. That one's in the right spot. But my s is in the wrong spot because of that negative exponent. So instead of being in the negative, in the denominator, I need to flip it up to the numerator. So that will become s to the 10th. And I can put that over 1 if I want, but I don't need to. Number 6, my numerator so far looks like there's nothing to simplify because my r and my s are different variables. So r and s squared, but in the denominator I have parentheses and I've got an exponent. So I've got to take that exponent and apply it to everything inside that parentheses. So I get r to the 1 times 3, because this r is really to the first power, and then s to the negative 1 times 3. And I can continue my process. So I've got r s squared on the top. On the bottom, r to the 1 times 3 is r cubed. S to the negative 1 times 3 is s to the negative third. The next thing that I notice is this negative 3 on my s exponent. That means I'm in the wrong spot, so I've got to flip it to the top. So I take r s squared, and then my s to the negative third becomes an s cubed on the top. On the bottom, I have an r cubed. And now I need to combine my r's and s's. So I can deal with either my r's or my s's first. I think I'll deal with those r's first. So I have r, 1 on the top and 3 on the bottom. So I can think about this as being r to the 1 minus 3 because of the quotient of powers property. And then I also have s squared times s cubed. That's our product of powers property. So I say s to the 2 plus 3. And that's all over 1 right now. R to the 1 minus 3 is r to the negative 2. And then I have s to the 5th. I'm almost done, but I have that r with a negative exponent, so that means it's in the wrong spot. You need to flip it to the bottom. So I get s to the 5th over r squared. If you don't need all of those steps, if you don't need to write them all down, you do not have to, but that's where every single piece comes from. Again, we weren't done until we only had each variable written once and we had all positive exponents. Okay, a couple more. Number 7. I've got to decide kind of what to do first here. If you see parentheses, that's probably a good place to start. So I notice that I have this 2 as an exponent with parentheses. I know that my 2 has to apply to everything inside those parentheses. So I'm going to have a 7 squared. And then a b, a power raised to a power. I multiply my powers. So I go negative 3 times 2. And then I haven't done anything with the b to the 5th yet. Or the b, I'm going to put a 1 on there because anything just one time is raised to the 1st. Now we can simplify. 7 squared we know is 49. B to the negative 3 times 2 is b to the negative 6th times b to the 5th and b to the 1st. B to the negative 6th, b to the 5th, and b to the 1st are all multiplied by each other. So that's a product of powers property. So b to the negative 6 plus 5 plus 1 is going to be b to the 0 power. We saw above that anything to the 0 power is going to be 1. So b to the 0 is just 1. So my final answer is 49. Again, if you didn't need to list every single step there, that's totally fine. Number 8, you want to decide where do you want to start. I usually start with my parentheses. I see this 2 in my exponent next to the parentheses. I have to multiply, or I have to bring that into every single piece. So I have x to the 1 times 2, because this is really raised to the first. Y to the 2 times 2, all over x to the third, y to the negative first. X to the 1 times 2 is x squared, y to the fourth, over x to the third, y to the negative 1, I notice first that this y to the negative first is in the wrong spot because it has a negative exponent. So I'm going to move it to the numerator. I get a y to the first. In the denominator, I'm still left with an x cubed because I didn't need to move that one. The exponent was positive. Okay, now I'm going to deal with my x's. I see that I've got an x squared on the top and x to the third on the bottom. So I can go x squared minus 3, so x to the 2 minus 3. And then my y's, I get y to the 4 plus 1. We have x to the negative 1, y to the 5th. And I know that x to the negative 1 means I'm in the wrong spot. Flip me to the bottom. So my y to the 5th can stay, but my x needs to go on the bottom. You can write x to the first if you want, but you don't really need to because x to the 1 power is just x. Make this a little smaller. Okay, we got one more. Number 9 says, I've got a whole expression all raised to the 3rd power. I know that that 3rd power has to be applied to every single piece inside of my parentheses. So I'm going to go ahead and just do all of that first. So numerator first. I have a to the 2 times 3. B to the 1 times 3, because that 1 is really on my b for my exponent. In the denominator, I have a to the negative 1 times 3. B to the 5th. In the numerator, I have a to the 6th. B to the 3rd. In the denominator, I have a to the negative 3rd, b to the 5th. And then I can do some simplifying. I can deal either with my x or my a's or with my b's. It doesn't really matter which one I go for first. I see that negative exponent is going to flip to the top. So I'm going to make this a to the 6th, a to the 3rd, b to the 3rd, and then my b to the 5th is still on the bottom in the denominator. A to the 6th and a to the 3rd is a to the 6th plus 3. And then since I have a b on the top and a b on the bottom, that's the quotient of powers property. I'll say b to the 3 minus 5. I have a to the 9th, b to the negative 2, since 3 minus 5 is negative 2. That negative means I'm in the wrong spot. Flip me to the bottom. So my final answer is a to the 9th over b squared. Make that just a little smaller. So that's a step-by-step process through all of these different simplifications of exponents. But the last thing that I'll leave you with is a simplified algebraic expression contains only positive exponents and every single variable is only written once. So as you're going through all of your practice problems, Make sure that you're not stopping until you have all positive exponents and every variable is written once. I will see you guys later.